5:20 in the afternoon, Monday, August 24th, 2026. In the wine country of southern France, between the medieval walls of Carcassonne and the small town of Limoux, a dark, rotating column of cloud drops out of a violent supercell thunderstorm and starts moving directly toward a village most of the world had never heard of. Pomas, population 1,000. Within minutes, roofs are being torn clean off houses. Cars are destroyed where they're parked. A pregnant woman is injured when her own home collapses around her. By the time the funnel finally lifts, roughly 300 homes across this one small village have been damaged or destroyed. 41 people are injured, 2 of them critically, and more than 1,000 households across the surrounding communities are sitting in the dark without power. If you'd told most residents of the Aude region a week earlier that a tornado violent enough to level entire streets was coming for their village, they would have told you that simply doesn't happen here. And in the most literal, statistical sense, they'd have been almost right. Here's exactly what struck Pomas, why a tornado of this intensity in mainland France is genuinely rare rather than routine, and what meteorologists are actually saying about whether events like this one are becoming more likely. No dramatizing, no guessing, just what French authorities, Météo-France, and the meteorologists tracking the storm have directly confirmed. If severe weather stories like this matter to you, subscribe now so you don't miss the next confirmed update, and hit like so this reaches more people who need the real picture instead of the panic. Let's break down exactly what happened in Pomas. Start with the confirmed sequence of events, because the scale of destruction from a single tornado striking a village this small is worth understanding in full detail. According to the prefecture of the Aude department, the tornado struck Pomas at approximately 17:20 local time on Monday, August 24th, 2026. According to CBS News, coverage citing local authorities, the storm hit hardest directly in the village itself, damaging an estimated 300 homes, in some cases ripping their roofs off entirely. More than 120 emergency workers were deployed to the scene, with reinforcements called in from neighboring departments to help. According to the Aude sub-prefecture, 39 confirmed injuries were reported, with separate reporting from CNN and CBS placing the total closer to 41 once additional assessments were completed, 2 of them in critical condition. Alain Bouquet, the head of the local government office, said 20 of the injured were hospitalized, with none in critical condition. As of Tuesday evening, a slightly different figure from the initial critical injury count, consistent with how these numbers typically get refined as medical assessments continue in the hours following a disaster like this one. Among the injured was a pregnant woman, hurt when her own house collapsed on top of her, according to her husband, who spoke with AFP in the storm's immediate aftermath. The tornado wasn't an isolated freak funnel appearing in isolation either. It formed directly beneath what meteorologists specifically identified as a violent supercell thunderstorm, the same type of rotating storm structure responsible for producing the most intense tornadoes anywhere in the world, including across North America's Tornado Alley. According to Météo-France, the National Weather Service, winds associated with this storm system reached up to 117 kilometers per hour, approximately 73 miles per hour, in the nearby village of Arquet-en-Val. Eyewitness footage captured from the neighboring village of Verzeil and separately from Villefleur showed the funnel actively forming and swirling beneath dark, violently rotating storm clouds before it swept directly across Pomas. The broader storm system responsible for spawning this tornado caused disruption well beyond the immediate tornado track. According to France 24, the severe weather forced officials to cancel a stage of the Vuelta, a España cycling race, and according to CBS News, storms across southern France disrupted the transportation network nationally, delaying trains, forcing road closures, and causing flight delays and cancellations at airports as far apart as Bordeaux, Marseille, Nice, Toulouse, and even Paris to the north. According to the Watchers, a science news outlet tracking the storm's aftermath in detail, approximately 1,400 households across the affected area remained without electricity as of 8 a.m. local time the following morning, with firefighters and specialist teams continuing reconnaissance and building safety assessments well into the following day. Local authorities opened emergency accommodation centers for displaced residents, with many spending the night at the Pomas Town Hall supported by the French Red Cross, while others stayed with relatives or in neighboring unaffected communities, and access to the most heavily damaged areas remained restricted while inspections continued. It's worth being direct and precise here about the specific claim in this story's headline, an F3 rating, because responsible coverage of a tornado's intensity requires understanding exactly how that classification actually gets assigned, and being honest about what has and hasn't been officially confirmed at the time of this report. Tornado intensity in France, as in the United States, is typically assessed using the enhanced Fujita scale, or in some cases the closely related international Fujita scale used more broadly across Europe. both of which rate a tornado's strength not by direct wind measurement, but by conducting a detailed damage survey after the fact, examining exactly how buildings, trees, and other structures along the tornado's path were affected, and matching that observed damage against a standardized set of engineering benchmarks. On the enhanced Fujita scale specifically, an EF3 rating corresponds to estimated wind speeds between 136 and 165 miles per hour, and is officially defined as producing severe damage, including entire roofs and some walls torn from well-constructed houses, a description that lines up closely with the kind of destruction reported across Pomas. Roofs ripped off homes, structures collapsing, widespread damage to a large share of the village's housing stock. That kind of damage pattern is genuinely consistent with a strong tornado in the EF2 to EF3 range. As of this report, however, French meteorological authorities had not yet publicly finalized an official numerical rating for the Pomas tornado specifically. A formal damage survey of this kind typically takes investigators several days to complete thoroughly, examining construction quality, debris patterns, and structural failure points by building before a final classification is confirmed. Given the scale of roof loss and structural damage already documented by AFP, Reuters, and multiple French officials on the ground, an EF2 or EF3 range classification is a reasonable damage-consistent estimate. But it's worth being upfront that the fully confirmed official rating may still be pending or freshly released as more detailed survey work concludes. Now, here's the part of this story that genuinely earns the word rare, and it's worth understanding with real precision because the instinct to describe any tornado as impossible in a given country is almost always an overstatement, even when the underlying surprise is genuinely well-founded. According to Météo-France, cited directly in coverage from both the Washington Times and the Watchers, mainland France records an average of a few dozen tornadoes every single year, and the agency has been specific that most of them are low-intensity events, brief, weak funnels causing minor, localized damage rather than anything approaching what struck Pomas. According to the Watcher's detailed geographic breakdown, tornadoes overland in France are observed mainly between May and October, with the northwestern part of the country and the Mediterranean coast, the exact region including Aude, among the areas most exposed to them. So tornadoes themselves are not some entirely foreign, unprecedented phenomenon for France. Dozens occur most years. What's genuinely uncommon is a tornado of this specific intensity and this scale of destruction. Recent French tornado history bears that distinction out clearly. According to Wikipedia's documented list of European tornadoes rated F3, EF3, or IF3 since 2020, France has recorded a small handful of tornadoes at that intensity level over the past several years, including a significant IF3 tornado that struck the town of Bihocourt during a broader European tornado outbreak in October 2022, an event specifically documented as the strongest tornado to hit France since a separate IF3 tornado caused significant damage near Etretat back in June 2013, nearly a decade earlier. That comparison alone tells you something important. A genuinely intense EF3 caliber. Tornado striking mainland France is the kind of event that, historically, has occurred roughly once every several years, not something that happens routinely as part of an ordinary storm season. And it's worth noting, for full and complete context, that France's tornado history does include events even more extreme than that. According to documented historical French tornado records, the country has recorded 2 tornadoes at the absolute top of the scale, F5, EF5, or IF5 intensity, in its full written history, one that struck Montville in 1845 and a second that hit Pas-de-Calais in 1967, both officially recognized by the European Severe Storms Laboratory. So France's severe weather history, while genuinely dominated by weaker events in most years, does include documented precedent for tornadoes considerably stronger than what struck Pomas, even if such events remain statistically rare across any given decade. That historical context matters enormously for correctly interpreting this story's headline claim that a tornado like this was impossible just yesterday. In the most literal, technical sense, it wasn't impossible at all. France has a real, if comparatively modest, tornado climatology, and events at this intensity level have happened before, including as recently as 2022. What's genuinely striking and worth taking seriously without exaggerating it into something it isn't is the rarity and the scale of destruction involved. A tornado powerful enough to damage or destroy roughly 300 homes in a single small village, injure more than 40 people, and disrupt national transportation infrastructure across multiple major cities is a considerably more severe event than the vast majority of the few dozen tornadoes France records in an average year. So what's actually driving tornado formation in a region not typically associated with this kind of severe weather? And is there a genuine evidence-based reason to expect more events like this one going forward? Here, the honest scientific answer requires real care because the physical ingredients that produce tornadoes are well understood. even while the specific question of whether climate change is measurably increasing tornado frequency or intensity in any given region remains an area of genuine, active, and still developing scientific research. Tornadoes form when several specific atmospheric ingredients come together simultaneously: warm, moist air near the surface, colder, drier air aloft, and significant wind shear, meaning wind speed and direction changing meaningfully with altitude, creating the kind of rotating, unstable atmospheric environment capable of spinning up a supercell thunderstorm and, under the right additional conditions, a tornado within it. Southern France, and the Mediterranean coast specifically, can genuinely produce that combination of ingredients under the right seasonal and synoptic weather conditions: warm, moisture-laden air moving up from the Mediterranean Sea, colliding with cooler air masses, precisely the kind of interaction responsible for this region's documented, if comparatively modest, history of tornado activity. It's worth being direct about the current, honest state of the broader climate science question here, rather than either overstating or dismissing it. Multiple lines of climate research have documented that a warming atmosphere holds measurably more moisture, roughly 7% more for every additional degree Celsius of warming, and that additional atmospheric moisture and energy can, in principle, contribute to more intense convective storm systems generally, the same broad thunderstorm category responsible for tornadoes, damaging hail, and destructive straight-line winds alike. However, directly and specifically attributing any single tornado, including the one that struck Pomas, to climate change, or even confidently establishing a clear, statistically robust long-term trend in European tornado frequency and intensity specifically, remains considerably more scientifically complex and contested than the equivalent research on heat waves or heavy rainfall events. Tornadoes are notoriously difficult to study at a climatological scale precisely because they're so localized and short-lived, and historical tornado records, especially outside the United States, have often been inconsistently documented across different decades, making long-term trend detection genuinely challenging even for dedicated meteorological research organizations. The honest, responsible position, reflected in how legitimate meteorological outlets have covered this specific event, is that this tornado fits within France's documented, if statistically uncommon, existing tornado climatology, while the broader question of whether events at this intensity are becoming measurably more frequent specifically because of a changing climate remains a genuinely active area of ongoing scientific study, rather than a settled, confidently established conclusion either way. It's also worth understanding exactly what French authorities are doing in the immediate aftermath, because it reflects a genuinely serious, well-organized emergency response to an event that, while statistically rare, was clearly treated with real urgency once it occurred. According to Euronews, the prefecture of the Aude department confirmed that more than 120 firefighters were deployed to Pomas, with reinforcements from neighboring departments called in to assist, and that operations to secure damaged and structurally compromised buildings were actively underway in the storm's immediate aftermath. Search and rescue teams continued working through the ruins the following day specifically to confirm that no residents remained unaccounted for, and according to the Washington Times, no people were reported missing as of Tuesday evening. A genuinely significant outcome, given the scale of structural destruction across the village, one that speaks directly to both the effectiveness of the emergency response and, likely, some combination of storm warning and fortunate timing that gave residents at least some opportunity to seek shelter before the tornado's most destructive phase struck. So, pulling this together, here's the honest, complete picture of what actually happened in Pomas and how seriously to take the specific claim that this kind of tornado was impossible until now. On August 24th, 2026, a violent supercell thunderstorm produced a tornado that struck the village of Pomas in southern France's Aude department, damaging or destroying approximately 300 homes, injuring at least 39 to 41 people, 2 critically, and disrupting transportation infrastructure across multiple major French cities. Damage consistent with EF2 to EF3 range destruction, roofs torn from well-built structures. Widespread structural collapse has been directly documented by multiple news organizations and French officials on the ground, though a fully finalized official intensity rating from French meteorological authorities may still be pending at the time of this report. This specific level of tornado intensity is genuinely rare for mainland France, though not literally unprecedented. The country has documented several EF3 or stronger tornadoes over the past decade, including a notable event in 2022, and even to historical F5 level tornadoes in its written record dating back to the 19th and 20th centuries. And while a warming atmosphere provides a well-understood, physically plausible mechanism by which severe convective storms generally could become more intense over time, directly and confidently attributing this specific tornado, or clear long-term trend in French tornado activity overall, to climate change remains a genuinely open, actively researched scientific question rather than a settled conclusion. If there's a practical takeaway from a story like this one, it's less about any specific region needing to fundamentally rethink its relationship to severe weather overnight, and more about a broader, useful reminder that even historically low tornado risk regions like mainland France do experience genuine, damaging tornado events on a recurring, if infrequent, basis, and that basic severe weather awareness, knowing how to take shelter quickly, staying informed through official weather alerts during active storm warnings, remains worthwhile guidance regardless of how statistically rare an event like this one actually is in any given location. That's the complete, honest picture of what struck Pomas this week. Not exaggerated, not softened, just what French authorities, Météo-France, and the journalists covering this story directly on the ground have actually confirmed about one of the more destructive tornadoes mainland France has recorded in recent years. We'll keep tracking this story as the official damage survey and intensity rating are finalized. If you live in France or anywhere else that's experienced a tornado yourself, drop a comment and let me know what it was like. And subscribe so you're the first to know the moment this rating is officially confirmed. See you in the next one.